So the first thing it says is find the volume of the solid bounded by, so y equals 9, y equals x squared. Okay, those are the two areas. That's where it's being bounded. So that's where we're going to graph. We're going to do a graph right here in a second. Bases of the cross sections are perpendicular to the y-axis. Okay. So perpendicular to the y means dy. And we have a square. We've done squares before. Right, the first one we did was a square. Square, the area of a square is side squared or x squared or whatever, because length times width, base times height, they're both exactly the same. So find one side, you know them all. Okay. So next thing, let's look at a picture. These aren't that hard to draw, but since we have the calculator, let's use the calculator. Okay, so let's draw a picture. So the first one is y equals 9. Order doesn't matter. The first one, they usually give the color red, second one blue. So all that matters will be the colors. So if you accidentally put the wrong one in first, it's okay. It's just your colors will be different. Okay. Okay, so this is what we're looking at here. This is the area, this is the part of the graph, of both graphs, that we want. So the bounded part, the part that's inside, it looks like the red is the top, and then the blue is the bottom, right? And this is the x-axis down here. Okay, so the area bounded is inside the parabola. Right there. Okay, so draw that picture on there. I'll give you some time to draw that. So you have something to draw on. It's important to see it, which you can see on your calculator, but it's also important to be able to draw on it because you're going to need to. Okay, so this rectangle, or this, not rectangle, this square, that base there, the base in green, the base that I've highlighted in green here, that's going to sit up. So it's going to come out and sit up, and it's going to sit right on top of there. So you're going to have a bunch of squares coming out like this. Okay. So what we want to know is, what is the length of the green? If the green goes from one side to the other, what's the length of the green? How far That's going to be part of our, because it's side squared. So volume is side squared. So that's why I have the squared part in the equation. I just need one side. So I just need to know the distance from the green of the green segment. Okay, so let's write down what I have on my graph. So I have y equals 9. The blue is y equals x squared. Those are the two things they gave me. Okay. Well, the first part, that's a little bit that I need to change. The first part that I need to change is that this is dy, right? This is dy. So anything I put into my equation here can't have an x, has to have y's only. So I have to solve for x, okay? Well, this guy isn't going to have anything to do with the length because I don't care about the red. I just care about from one side of the blue to the other side of the blue. So the only one I really care about is y equals x squared. So that's the only one I'm going to solve for x because I don't want any x's. I want it to say x equals, not y equals. Okay? So we've done this before. So solve for x, right? You're going to take the square root of x, or the square root of both sides, I should say. So you'll get x equals plus or minus the square root of y. So when y is positive, you're going to use the positive. When y is negative, you're going to use, when x is positive, you're going to use the positive version. When x is negative, you're going to use the negative version. Okay? So let's look at the blue. Let me get rid of this since we're not going to use that anymore. Let me relabel it. So when is x, so just the blue. You're not looking at the red anymore. Don't worry about the red. Just the blue parabola. When is x positive on the blue parabola? So y is always positive because it goes up, right? Y is always positive. But when is x positive? On one side, right? This side, right? This side, x is positive. This side, x is negative, right? So this side, oops, not y, is going to get a y equals positive square root x. Or, sorry, square root y. This side is going to get a negative square root y. Okay. So if we want to find the distance from one green dot to the other, well, first of all, go back a few lessons. What are we going to do? The right side, so to find this distance here, I'm going to subtract the two, right? I'm going to subtract the two. Which one do I do first, the right or the left? Which one did we do a few lessons ago when we were doing dy, remember? We did top minus bottom when it was dx. What did we do when it was dy? Right minus left or vice versa? Right minus left. We did right minus left when we were doing dy. That's what we're going to do now. So the right green dot represents positive y squared, or positive square root y. So this guy here is positive square root y minus the other side, negative square root y, which makes a plus plus, right? And so you can't subtract a negative. It's a double negative. So it's really positive. So that is the distance from green dot to green dot. So that's what we're going to put in here. Because this is the distance of one side. To find the area, you're just going to square that side. Okay. So another way of, so you can leave it like that. It's 2 square root y. That's essentially what it is. Okay. Okay, so now the bounds. What is the bottom? So this is dy. So we're not looking left and right bounds. We're looking top and bottom bounds. So 0. So 0 would be the bottom bound. And where's the very top? Positive 9. Okay. Last step, calculator. So throw that into your calculator. You should get 162. Okay. Okay. Example B is exactly the same. The only difference with example B is instead of squares, it's semicircles. Okay, which we've done before. So for 2B, first thing we'll do, let's redraw the picture. Let's redraw the picture. Picture that we had earlier, we're going to use that picture again. So redraw it. I'll give you some time to redraw it. Because it's the same picture, but we're going to do different things to it. It's still the bounded area. The bounded area is still in here. Okay. We still have y equals 9 and y equals x squared. This one is still perpendicular to the y-axis. So that means dy. The only difference is we have half circles instead of squares like the last one. Okay. Okay, so we know area of a half circle, pi r squared divided by 2, or 1/2 pi r squared. Okay? This says it's perpendicular to the y-axis, dy. So I'm going to change this one again to what we had earlier. Because anything I plug into my final equation, I can't have an x. It's got to only have y's. So let me write this down here. Volume equals something dy. Not ready to do anything with it yet, but I know it's going to be dy. And I know anything I plug into it has to have only y's. Okay. Okay. So again, these these semicircles are going to go from, they're going to stand up right this side here. This base here is going to stand up from here to here. All along, they're going to cover that orange space. So you're going to have a bunch of half circles sitting like this. So some are going to have longer diameters than others. Okay. So this one's going to kind of have this oval shape, or sorry, a curved shape here, because all the half circles will be extending out. Okay. All right. Okay, so the green line, the green dot to green dot, does not represent, we have the same issue we had on the last one we did with semicircles. The green dot to green dot isn't R. It's diameter, right? So we need to change our equation, our area equation, to have diameter. We've already done this though, so we don't have to do it again. So what was the area? What was the area formula with diameters in it? Go back to what we did yesterday. It was pi times d squared over 8. Pi over d squared divided by 8. This guy right here. That was the formula. Same formula, but using diameters instead of radii. Pi times d squared over 8. That's the one we're going to use, because the diameters are the one that go from green dot to green dot. Okay. All right, so area. Where does the diameter extend from? From right to left, where does the diameter extend to? Extend from or to? It extends from the same area, right? Positive square root of y to negative square root of y. So this is going to be positive square root of y minus negative square root of y, which ends up being positive, right? So in there I get 2 square root of y. And this is squared over 8. You can clean this up a little bit. You can square. If I square 2, it becomes 4. If I square the square root of y, it just becomes y. So it's 4y pi over 8, or you can just leave it like that. Either one is okay. So that I'm going to plug in here. So pi times 4y over 8. Okay, because if you square 2, you get 4. If you square y, the square root, you get y. Bounds are going to be exactly the same as the last one. Top bound is 9. Bottom bound is 0. Plug it in. You can even simplify this. You can say this is 1, divide them both by 4. You can do that too. So you can put pi times y over 2. That's okay as well. So when you plug that in, you should get 63.617. That would be the volume. Okay. Okay, so we've done two examples. I think we did three examples perpendicular to x. We did 2 examples perpendicular to y. Now I want to skip number 3 because number 3 is more of kind of the same. I want to go to the last one, the very last example that has 3 parts. Like I told you guys yesterday, this comes from a former FRQ question that I used to use, but I used it enough, so I stopped using it. I picked another one, and but still a good problem. So I wanted to put it on the notes just to kind of give you practice of what you will see. This is the kind of FRQ problem to expect next week. Okay? So it's a good problem to work together because this one deals with not only volume, but it also deals with area. One of the first things we did was we talked about area between curves. Okay? Okay, so let R be the region in the first quadrant bounded by the x-axis and the graphs of, there's 2 graphs here. There's y equals natural log of x and y equals 5 minus x. Okay? Now, y equals natural log. That's a curve. Y equals 5 minus x. That's a straight line. Okay? If you didn't know, put them both into your calculator and you can figure out, it color codes it for you. Okay? It's a calculator question. So the yellow is going to be the curve. And the blue is the straight line. So this is y equals natural log of x, y equals 5 minus x. Okay. So the first thing we need to do is we need to find the area. R, find the area. I'll highlight that in a different color. Pick orange. Find the area of the orange stuff. Not volume, area. Okay. So going back, I know this is a while because area we did not too long ago, but it was before spring break. We have 2 options. I can go area between curves, top minus bottom, top curve minus bottom curve, or I can do area right minus left. Doesn't matter. You can actually do this problem using both, but whichever is easiest. Okay, so let's look at this problem here. If I want to find the area of the orange, would I use top minus bottom function of the orange, or would I use right minus left? I would use right minus left. Yeah, I would use right minus left. Why? Because I could do it. If you wanted to do top minus bottom, you'd have to do it in 2 different pieces. The yellow so you have to split it up into R1 and R2 because The yellow is the top for this part. The blue is the top for this part. All right. But if I did it right minus left, I could go for the whole thing. Okay. So like I said, you can do it using top minus bottom or right minus left. It doesn't matter, but it's up to you. Okay. Okay. So let's go right minus left. So going back to our notes, area equals right curve minus left curve. So let's do that first. So R, area of R equals top curve minus bottom curve. And since we're doing it this way, we have to do dy. Okay. We have to use dy. So only y's. I can only put things with y's in here. I can't put things with x's in here. Okay. Okay, so right curve. So we're going to go from the right side to the left side. So the right curve is this guy here, but it has an x inside, so I have to solve it for x. Divide by -1, divide by -1, I get x equals -y plus 5. I solved for x. So that's the right curve. -y plus 5.
Mr. Flores, would the negative be distributed from the... Oh, I see what you did.
Yeah, I divided them both by -1. So y divided by -1 is -y. -5 divided by -1 is +5. Yeah. Okay. Minus the left. Well, the left guy is y equals natural log of x. So how do I solve this guy for x? My question is, how do I solve this guy for x? I can't add or subtract or multiply or divide. How do I solve this guy for x? Do what? So so luckily this is exactly what I'm teaching in my Math 3 class, so I have it on the board. So the natural log, we know the base. The answer is y, right? To change it over here, the base is going to go here, right? The base is e. So this guy is going to start with e. And then the exponent. Well, the exponent is located over here. So that's going to be the new exponent equals x. Okay. It's essentially the loop trick. It's essentially the loop. That's what I did. So that's the right side. So e to the y. Now the bounds. Well, the bounds are bottom and top. If I'm doing dy, it's got to be top and bottom, not left and right bounds. So where would the bottom of the orange be? Y equals 0, right? The x-axis. Y equals 0. Where would the top be? The top is right here. I don't know what that is. I just know it's where they intersect, right? How do I figure that out? Graph it, yeah. So graph it and figure out where they intersect. When you're graphing it, use the y equals. Use the y equals versions to figure out where they cross. It's good practice with the calculator. So use the y equals versions when you're trying to figure out where they cross. Okay. So I want to know where the blue and the red cross. So I go up to calculate, pick one. It doesn't matter which one. You can pick the blue, you can pick the red, whichever one you want to pick. And then I want to find intersection. And it says there's only one intersection. X is 3.693. Y is 1.307. Okay. Okay, so which of those am I going to use? 3.693 or 1.307? 1.307. There you go. Because that's the y, because it's dy, so I only want the y's. Last step, throw in your calculator, see what you get. Let's see what I get. $2.985. 2.985. That's the area. Oh, did I round her up? Let's see. 986. Yeah, you're right. 986. Okay, perfect. Okay. So B and C, we don't actually have to solve. We just have to set up. Okay, so that means give me the equation. I can do the calculator part. Give me the what you would put in the calculator. Okay, so region R has a cross section that is a square. Okay, it's perpendicular to the x-axis, so that's dx, right? So we're going to do volume equals, this is a dx guy, right? It's a square, area of a square is side squared, like we've done before. So this side is going to sit perpendicular. This one is perpendicular to the x. So it's going to sit here. It's going to sit like this. Okay, that's where it's going to sit. If it sits like that, what's the problem we're going to have when we try to? It's not a problem, but it's something we definitely need to take care of. What's the issue we're going to have when we're trying to find the volume? It's going to switch, right? It's going to switch at that black dot. It's going to switch here. It's going to be green minus the x-axis, and then at the dot, it's going to be blue minus the x-axis, right? That's okay. So we're just going to have to split this guy up into two. We're going to split this guy up into two and add them together. Okay. The first part will be that. The second part will be over here. Okay. So let's do the first one, the yellow. So let's just take a look at this part right here. So just this part right here. So the distance would be top minus bottom. Well, top is natural log of x. Bottom is y equals 0. So it's going to be the natural log of x minus 0. That's going to be the length here. So to find the area, we're going to square that. Okay. So now the bounds. Since it's dx, the bounds are going to be left to right. Well, left, the very left, x is 1, right? So it's going to be from 1 to that dot there. So from 1 to 3.693. It's going to be from 1 to 3.693, right here, cut it in half. And then the other one will be from 3.693 to 1, 2, 3, 4, 5. And that'll cover the whole thing because the whole thing goes from 1 to 5. Okay, so we did part of it. Now we got to do the other part. We got to do this part now. This part. Well, again, it extends from top minus bottom. The only difference is this is top is y equals 5 minus x. So it's 5 minus x minus 0 squared because it's a square. And that's it. That's as far as they want us to go. If I wanted to, I could put that in the calculator, but it's not saying to do it. It says do not evaluate. Do not evaluate means don't give me an answer. Evaluate means give me an answer. It says write, but do not evaluate. So they don't want an answer. They're asking for no answer. They just want, how would I get the answer? Okay, one more. Last one. So this one is perpendicular to the y and it's a semicircle. Same shape. Same shape. So now it's perpendicular to the y. So now semicircles, diameter of semicircles are going to go from here to here. Diameters of semicircles are going to go from there to there. And then you're going to have the semicircle is going to be sitting like this. So it'll be sitting kind of like this. Okay. So from earlier, we know that the area of a semicircle is pi times diameter squared divided by 8. And the diameter is going to go from one side to the other side. It's going to extend from here to there. That's the diameter. Right minus left, except this is dy. So we're going to use the x equals guys. So this guy minus this guy is going to be the diameter. Okay, so we got pi times diameter squared over 8 dy. The diameter goes from the right side to the left side. Negative y minus plus 5 to e to the y. Okay. All right. Last thing, I need the bounds. Since it's dy, the bounds go from left to right. Or sorry, top to bottom. Sorry, top to bottom. Top to bottom. So the bottom would be 0, right? The bottom of this shaded part is 0, the x-axis. And it goes up to that black dot, 1.307. 1.307. Done. That's what I would put in my calculator. They're not asking you to put it in your calculator. It says do not evaluate. So you're done. Because if you can get that far, you're going to get the right answer. As long as you put it in the calculator correctly, which you should, you get the right answer. Okay, that's why a lot of times they just ask you to evaluate, or just ask you to write it, don't evaluate. Okay. All right.